Good morning, ladies and gentlemen. Today I am at the board office in some meetings, so you have a substitute. He or she should have already collected your homework that was due today, and you are now, I'm sure, familiar with how these videos work. You're going to watch the video and fill in your notes. Remember, you can pause, restart, and play these as much as you need to get your notes filled in. Okay, let's start with our homework today. It says Chloe and Jonas are solving that compound inequality. The first thing I want you to realize is this compound inequality is an and inequality. We talked about this a couple days ago. That is an and inequality. So I want to know, is either of them correct? Now remember, with these inequalities, you need to isolate the x in the middle. So in order to isolate the x in the middle, these two students should be adding 5 to both sides. Now, actually, I misspoke. It shouldn't be both sides. They should be adding 5 to all 3 pieces. When you do that, the middle cancels, and 7 plus 5 is 12, and 3 plus 5 is 8. Uh-oh, Chloe did not have an 8 over there, so Chloe is not correct. Let's look at Jonas. He needs to add 5 everywhere. The 5's cancel in the middle. 3 plus 5 is 8. That's good. And 7 plus 5 is 12. Uh-oh, Jonas did not add over there. So Jonas is not correct. So neither of these two students are correct because they did not add 5 to all 3 portions of the inequality. All right, if you look at the top of your notes today, it says inequalities involving absolute values. So today, if you look at the bottom, you have absolute value inequalities. Well, the first thing I need you to do is remember what we do with an absolute value equation. Remember, equation means that we have an equal sign. Okay, when that is the case, the first thing you had to do was make sure that the absolute value was all by itself. It is. And then you had to set up 2 different versions, the positive version and the negative version. And then from that, you just solved it like normal. So if I want to isolate the y, in the positive version, I get 30. If I want to isolate the y over here, I get negative 10. Okay, so we had 2 different versions, the positive and the negative, and we got 2 different answers. Today, we'll be looking at absolute value inequalities. So that means that you have a greater than or less than symbol and the absolute value bars. Now, I need you to remember that absolute values have infinite solutions, in which case we normally use shading. So you should be expecting that with these problems. All right, the first thing I need you to do is determine several values that will satisfy each inequality. So what can I put in for x? That when I take the absolute value, it is less than or equal to 2. Well, most people will first tell me 0. If I put a 0 in there, 0 is less than or equal to 2. I also could put a 1 in there. The absolute value of 1 is 1, which is also less than or equal to 2. Well, if I put a negative 1 in there, that should also work. Because when I take the absolute value of negative 1, it becomes 1, and that is less than or equal to 2. Now, those aren't the only numbers. We can put in decimals. We actually could put in negative 2 and positive 2 because of the equals bar in there. Okay, so all of the numbers in between negative 2 and 2 will work. The same thing will happen with number 2. If I want the absolute value to be less than or equal to 6, I can put in all of the numbers that when I take the absolute value, I get something that is less than or equal to 6. So that is all of the numbers between negative 6 and 6. Now, ladies and gentlemen, please don't forget that all of the decimals and fractions in between there would work as well. Well, I'm sure by now you can guess that if I want the absolute value to be less than or equal to 14, that would be all the numbers from negative 14 to positive 14. 0, 2, 10, negative 8, 6, And the same thing holds true for the absolute value being less than or equal to 8. Everything from -8 to +8 should work. Okay, so how do we actually solve these algebraically? Think of a less than absolute value inequality as the phrase less than. Less than. Now I know that seems silly, but I'm highlighting the word and, less than. Therefore, you will need to set up and inequality to determine the solution. The endpoints of the and inequality will be positive and negative versions of the original critical number. Okay, now I need you to remember that back here in our warm-up, these are and inequalities. The inequalities with 3 pieces are and inequalities. So that's what we are going to be setting up. So if we take a look at number 1 here, the first thing I need to know is the absolute value isolated? It sure is. The second thing I need to know is what inequality symbol do I have? This is a less than inequality. So I'm going to set up an and inequality. Just as your directions said, the endpoints will be the positive and negative versions. So over here on the left, I'm going to start with -3 because that's the negative version of that critical number. Is less than x plus 1. Notice I did not change anything about that except for taking off the absolute value bars. Is less than the positive version of that critical number, which is 3. And that's an inequality. It's an inequality that you should know how to solve. All right, let's look at number 2. The absolute value is all by itself. So on the left side, I'm going to put the negative version of this critical number. Is less than what's in the absolute value is less than the positive version, which is 3. And we'll be ready to solve. Number 3, the absolute value is all by itself. My critical number is 7. So on the left, I'll choose the negative version of that. In the middle goes what's in the absolute value. And on the right is the positive version. And then from here, we will solve them. All right, let's go ahead and do that. Let's solve all 3 of these. First things first, I need to isolate the x in the middle. So I will subtract 1 everywhere. When I do that, I get -4 is less than x is less than 2. And the x is isolated in the middle. So I'm ready to graph. My critical numbers are -4 and 2. Both of them get open circles. And because the x is in the middle, we shade in the middle. Number 2, I need to isolate the w in the middle. So I need to subtract 2 everywhere. I get -5 is less than w is less than 1. The w is by itself in the middle, so I'm now ready to graph. My critical numbers are now -5 and 1. They both get open circles, and because the w is in the middle, we shade in the middle. Finally, number 3 here. I need to isolate the k in the middle. So the first thing I need to do is add 2. I get -7 is less than or equal to 3k is less than or equal to 9. Now to isolate that 3, I'm going to divide by 3. I get -1.6 repeating is less than or equal to k is less than or equal to 3. And now the k is isolated. So my critical numbers are -1.6 repeating and 3. Both of these get closed circles, and the k is in the middle, so we shade in the middle. All right, that is your first set of less than inequalities. Flip it over to the back, and let's do 3 more. The first thing you need to ask yourself is that absolute value isolated? It is, so I'm ready to set up my less than inequality. My critical number is 1. So on the left goes the negative version, In the middle goes what's inside the absolute value, and on the right goes the positive version. Let's look at number 5. The absolute value is not isolated. So what is farthest from the absolute value on the same side? The 5. So in order to get rid of that 5, I will subtract it. I have 4. The absolute value of 2 plus 3t is less than 16. Now the 4 is attached to the absolute value. It's being multiplied. So I am going to divide by 4. And I have the absolute value of 2 plus 3t is less than 4. And now my absolute value is isolated. So I am ready to set up my less than inequality. My critical number is 4. So I'll put the negative version on the left, what's inside the absolute value in the middle, and the positive version on the right. We have the same issue in number 6. The first thing I need to do is isolate that absolute value. So I'm going to get rid of the 8 first. There's still a negative symbol outside. Now I got to get rid of the negative symbol. It's being multiplied, so I need to divide by negative 1. Oops, and remember, when you divide by a negative, you have to flip that symbol. All right, the absolute value is by itself. We have a less than inequality. So now I'm ready to set up my and inequality. My critical number is 1. So that goes, the negative version goes on the left. What's in the absolute value goes on the right. And the positive version goes on the left. And now, folks, we have, excuse me, I put an extra line in here. We have all of these things ready to be solved. Let's start over here with number 6, the orange one. In order to isolate the x, I need to subtract 1 from everything. This gives me negative 2 is less than x is less than 0. Well, the x is by itself, so I'm ready to graph. My critical numbers go on the number line. They both get open circles, and the x is in the middle, so we shade in the middle. Over to number 5, the black one here. I need to isolate the t. So the first thing I'm going to do is subtract the 2 everywhere. I get negative 6 is less than 3t is less than 2. Now I need to divide by 3. And I get negative 2 is less than t is less than. You can either leave that as 2/3 or do 0.6 repeating. All right, let's get my number line here. My critical numbers go on that number line. They both get open circles, and the t is in the middle, so we shade in the middle. My last one over here is the red one. Let's isolate the x in the middle. I get negative 6 is less than 3x is less than negative 4. Divide by 3. I get negative 2 is less than x is less than negative 1.3 repeating. The x is isolated. Put them on a number line. They both get open circles, and the x is in the middle, so we shade in the middle. All right, ladies and gentlemen, that is your section on less than inequalities. The next section will be on greater than inequalities, and for that, you will need to view the next video.